Thank you everyone for joining the training and welcome to the GoodWe Smart PV Designer. And our design tool is called the GoodWe Designer. And before we start it's going to be a practical session. So I'll jump right into how to log into the account, the GoodWe Designer account, and I'll demonstrate how to design a plant using the GoodWe Designer tool. But before that, let me introduce the GoodWe company portfolio. Sharing the screen. Okay. So yes, I'll take you through the solar PV design platform for the GoodWe. It's called the GoodWe Designer. And before we jump into the practical session, this will be our agenda. We'll go through the GoodWe company portfolio. Then our second session will be practical. I'll show you how to do designs using the GoodWe Designer tool. Then, as usual, we'll have the Q&A section uh, that will finish off the session itself. But yes, just as part of our monthly routine, we do have our webinars monthly. And for those in attendance, we also share the dates or the schedule for the upcoming webinar for next month. But just to put across, we do also have an e-conference with APSIA that it's already ongoing as of tomorrow. So tomorrow we'll have a session with GoodWe starting from 12:15 p.m. all the way to 12:45 p.m. And this will be talking into the trends that are coming up for the solar storage solutions in both residential and C&I sector. So right back into the today's sections, we start off with the company portfolio. So GoodWe is actually driving the world towards the smart energy future. That's our vision. And to put this into perspective, our mission is actually we are one of the major driving force globally. That is transitioning the globe towards a sustainable future or a sustainable energy source. And our products, we've particularly chosen the sun to be our free or renewable energy source, with our products generating and storing this power for consumption or for better consumption or sustainable future. Now, with the milestones of GoodWe, GoodWe was established in 2010. And during the first, as GoodWe was being established, we decided to focus into the PV inverters. So first off, we started as a residential PV inverter manufacturer, and we launched our first products in 2011, as well as our R&D research and development center in 2011. The products that we launched managed to garner a number of awards, the Photon AA Award 2012 to 2013. And this paved way for GoodWe to launch its first residential hybrid inverter into the Asian market in 2014. That's when the ES series was launched. And we managed to get in some traction globally. And that's why we managed to expand into the Australian market, uh, launch our own monitoring portal called the SEMS in 2016, expanded another manufacturing base in Guangdong. And in 2018, we established our headquarters in Europe, Germany, that is. And yeah, ever since, our products have been getting traction all over the globe. And after that, this is what actually established our foothold, and we got listed into the Shanghai Stock Exchange. So GoodWe is actually financially stable. And with that stability, we launched other subsidiaries like the BAPV, Building Integrated Panel Manufacturing Industries. And yes, since then, we've been expanding and into the African market, we established a number of offices. So we do have an office in South Africa, we have an office in Kenya as well, and we'll be opening another office in Nigeria to basically support the West African market. Well, opening offices doesn't mean we're not present, but yeah, we are present already in the West African market. We have support staff in Nigeria, in Ghana as well for the West African market. For the East African market, there is a team stationed in Kenya. Now, along the milestones of GoodWe, we've managed to garner a number of awards. These are very certified third-party bodies. So, for example, GoodWe was awarded #1 residential hybrid inverter supplier by Wood Mackenzie, and Wood Mackenzie also awarded GoodWe for being the global top 5 global PV inverter shipments. And our inverters have been getting a number of increasing on the efficiency, and we have an average of 94.9% in terms of efficiency. And for financial stability, Bloomberg NEF awarded GoodWe for being the most financially stable company. And the EcoVadis Award in 2022, Silver EcoVadis Award. And a number of our products are getting awards in terms of functionalities and features. So the top brand, GoodWe managed to garner a top brand PV inverter award for 5 consecutive years. We do have a Red Dot Design Award. And in terms of quality, because our products are of high standards and functionality, we do have a Tools Rainland Quality Award, which is for 7 consecutive years. And yes, we are very marketable, and that's why PV Magazine awarded GoodWe an award in terms of marketability. Now, production-wise, because the traction for the GoodWe products is very high, the market acceptance keeps increasing year on. GoodWe is able to manufacture 35 gigawatt of solar PV inverters and 2.1 gigawatt hour of lithium iron phosphate batteries. Now, these products are of high quality and of maximum efficiency. The GoodWe products have been installed globally, starting from the Asian market, European market, Latin America, Africa, and we are boasting of installing our products in more than 100 countries globally. This as of last year, June 2024. And the products are ranging from the smallest 700 watts to the biggest 350 kilowatt PV inverters. Now, the 8 total installed globally through our SAMS portal, we have managed to install 80 gigawatt of systems. In that section, we have 6.2 gigawatt on storage, energy storage inverters, and 34.5 gigawatt on residential inverters. GoodWe is also venturing into the utility scale sector, and we have managed to install 8.5 gigawatt of utility scale plants. The C&I sector, we do have products for that market as well. And at the moment, we have 30.8 gigawatt of solar inverters focusing on this commercial and industrial sector. The GoodWe portfolio is a bit broad. This is in the sense that we are capturing different market needs. As you know, Africa has its own needs, Europe its own needs, Asia and the likes. So our product range is quite broad, and we have a very wide portfolio. For example, the residential inverters, we have the smallest 700 watts to the biggest 30 kilowatt. These are grid-tied residential inverters. Then we have the commercial and industrial inverters from 25 kilowatts all the way to 125 kilowatts. Then the utility scale inverters from 225 kilowatts to 350 kilowatts. We also manufacture or design our own softwares. So the smart energy management system is the monitoring portal that we use. We also have our own configuration software mobile app called SolarGo. That's in-house designed. GoodWe has hybrid inverters or energy storage inverters from as small as 3 kilowatt to as big as 100 kilowatt inverters. We manufacture lithium ion batteries, strictly lithium ion phosphate batteries. And uniquely, we do have products for different market segments. For example, we have the AC EV chargers from single phase to 3-phase. We just established a new subsidiary as of last year. We have a subsidiary focusing on designing and manufacturing heat pumps. We also have a subsidiary for designing and manufacturing building integrated photovoltaic panels. And to give you just a brief layout or an overview of how the products looks like, these are now what, not all, but some of the products that we manufacture. As you can see, they are all aesthetically pleasing. They're compact, lightweight, less noise. Starting from the far left, that will be the high voltage links D. We have the ESG2, we have the ES unit, we have the on-grid inverters, utility scale inverters, all-in-one of the solutions, AC EV chargers, building integrated panels, and the like, stackable lithium-ion batteries. Now, these products are ranging from the smallest 700 watts to the biggest 350 kilowatt system. Now, that summarizes the GoodWe portfolio. Now, what I'll do, I'll just take you through practical session of designing a plant using the GoodWe designer. So this will be very practical. So forgive me, but I'll have to exit the PowerPoint, then connect or log into the GoodWe designer account. So the GoodWe designer account is actually an online tool. So you just have to navigate to your browser. And yeah, so what you do is just on the browser itself, you type GoodWe designer. So it will take you to this, let me say login. But first off, before you get to log into this, you need to have an installer account. So the reason why you need to have an installer account is because the GoodWe design is actually connected to your SAM's installer account. As you can see, the screen is prompting me to use my SAM's login to access the GoodWe design account. So before you get to use the GoodWe design account, we'll be sharing the installer link, SAM's account registration for installer accounts, which will give you access to the GoodWe designer. So once you register to the GoodWe designer, to the SAM's installer account, then all you need to do is just type in the GoodWe designer, then proceed by clicking GoodWe SAM's. Then automatically the link will take in your account login details from the SAM's, and then you just click on sign in. Yes. So these are a number of the projects that I've done, but for you, you'll get an empty slot in the project section. Now to prompt a new project, you just click on new project. Then you have to give it a name. Let's say GoodWe designer. Description, you can, now this is a plant. For example, you can describe let's say we're doing a C&I storage solution. Then you select the possible size of the solution in terms of acreage, or it will give you an aerial view of how the panels will be covering the aerial view, the size of the plant. So because it's most, for the C&I, we'll do medium. If it's a utility or a big C&I, you can do large, or these are just XL, extra large, all the way. So these, the 2XL and 3XL are for the utility size plants. So just bigger acreage of land to be shown. So I'll select medium. Then we'll be typing the location of where you'll be doing the installation itself. So for example, I'll choose the Kenyan location. Let me say Times Tower. So automatically it will zoom into the particular location. So whatever is in the square is what, let me say, working space that you have. So this is the particular building that I want to design my plant on. So it's actually centered, which is okay. Then you scroll down and select create project. So we have to choose which particular installation we're doing. It's basically a C&I. So I'll check the box for the commercial industrial. It's a three-phase, so you can do either single phase or three-phase. For this project, we'll be doing a three-phase. Then next step is to select the particular panel, solar panel that you're installing. So we have a number of solar panels already included on the list. So all you need to do is type in the name. So you can do JA 600 watt. It's already there. Select whichever panel you need. You can do Longi 555. It's there. Astro, Astronergy. So various third-party panel, let me say, brands are already enlisted in our system. But in case you find that your particular panel is not available in the list, all you need to do is just reach out to the after sales or even me, the pre-sales. You reach out through email, attach the data sheets of the particular solar panels that you'd like to add to the list. And in a span of, let me say, 1 or 2 days, the panel will be, the data sheet or the specification will be added to the list. Then you can use the particular solar panel. So for today, let's try JA600. Now, this is a cautionary thing. The account is automated to the point that it takes the specifications or the rating of the panel and compares it to the MPPT rating of the inverter that you're using. So if the panel has a lot of short circuit current surpassing the inverter MPPT rating current-wise, uh, then the account automatically informs you or prompts you, alerts you to say, for example, in this case, the current is exceeding the inverter rating. In short, it's more than the MPPT rating of this SDT inverter. So the particular inverter we'll use for C&I is an ET50. ET50 is now the hot product right now for the C&I storage. ET50, yeah. So automatically that prompt is cleared because now we are within the rating of the MPPT. So ET50, the battery, you can choose the BAT 56. BAT, yeah, 56. Then you can choose the particular rating or the storage size that you'd like to install. For example, we can do, how many? I'll have to do a simple calculation. So one inverter of the ET50 can do up to uh, six of the BAT 6.3 in parallel to one inverter. And the 50 kilowatt hybrid inverter can parallel up to 10 pieces. So maximum you can do is 500 kilowatt AC or 500 kVA AC. And for each inverter, if you do a maximum of 6, then 56.3 times 6, that gives you that, then times 10, gives you around 3.3 megawatt hour of storage if you're doing on the maximum end. 500 kilowatts, 3.3 megawatt hour. But for this, we'll just do a simple, let's say 2 pieces of ET50. Oh, let me put it more simpler. One piece of the ET50 inverter with probably 2 banks of battery. So we'll be doing 3 times 2. That's around 112.6. So I type in 112.6 kilowatt hour. So you can customize your, because this is a document that you'll be downloading and sharing with your clients, you can customize, add these data, they're optional. So you type in the client's details, full name, VAT, address, contact person, email, add the logo there, then optional project details and the likes, whoever you're partnering for that particular project, and any more observationals or any other details that you would like to add. So the critical technical part is the panel, solar panel. Well, after selecting the location, is whether it's single phase or three phase, the solar panel, the inverter, the battery model, and the size of the battery. Then the rest is just the personal details of your clients or the people you're partnering for the particular project or plant. Then you click save. Then you're done with the details part. Now we move to the tariffs and prices. Um, this is the, let me say, we'd like to do a whole year for 12 months. So we choose a whole year, 12 months. Then the price of the particular, let me say, charge of the local or the public grid. In Kenya, we can do around 29 Kenya shillings per unit. So depending on the country, the region, the date, the month, this, you can edit the price per unit from the grid side. Then you select whether you're allowed to feed to the grid or you're doing net metering or it's fixed, constant feeding, or zero feeding, zero export to the grid. For Kenya at the moment, it's zero export, so I'll be selecting zero export, no feedback energy. Then I click save. Then we move on to the consumption. The consumption is basically the consumption profile of the particular client. So previous consumption data from the grid, if you have it. So we can do monthly consumption, but basically there are two ways. You can either manually feed it here. So basically, let me say 20,000 units. So manually feed it there. So I'll show you all the options that you have. So January to December, you have that. Then the other option is to select the consumption file. So we have an Excel or CSV template. So you can download the template. Start date, let's say 1st June. So it takes the whole year from 1st June to the end of next year, same month. Period. So the period that you're choosing here is the interval of recording data. So if you have an Excel consumption data that inputs data every 15 minutes, then you choose the 15-minute interval. Most of the time for the Kenya Power Grid, you'll get it at 1 hour interval. So the best you can do, or if you've done data logging, then you can choose what preference you have. So I'll choose the 1 hour interval, then download. Yeah. So this is an Excel template that you need to fill. As you can see, it gives you the dates and the time, and the time is alternating in 1 hour. So midnight to 1 a.m. to 2 a.m. in that. Then you can fill in the consumption at 1 hour intervals from 1st June this year to next year June. So you fill in all that data. You can see you're scrolling down, it's a 1 hour interval consumption. So once you fill this data, you go back to this and upload your file. So you click upload, then you go choose the particular file that you need to upload and upload it. It will come back there. So that's the two options that are commonly used. The monthly physical, you input your data there from January to December. You can also choose the units that you want to display, whether it's in kilowatt hour, megawatt hour, joules, watt hour, whichever you prefer. So for this, I'll fill in 20,000 kilowatt hour from January to December, and my consumption is 240,000 kilowatt hour for this year. So I'll choose a flat profile. Basically, it's constant, so a flat profile. And yeah, click on save. Once that is done, you go to the editor. Now this is the section where you're doing the actual design and editing. So at the beginning, you'll just get an aerial view of the buildings around. So just like many other design tools, you can do the isometric view. But if I've not designed anything. So if I check it on the side view, nothing yet. So I have to construct my building. Whether it's a roof, a building itself, or a ground mount system, you have to set up the structure first. So this particular building is a bit complex. It's like a cross. So first thing I have to choose is roof. So I choose roof, then it prompts me to draw. So I'll pick the highest point. This is the highest point. So yeah, select that. So if you most complex systems are for the residential systems because of the roof designs. So for me, my roof is basically a flat roof. That's why I'm doing it all at once. If you have, I'll open another project. So to showcase you how you're going to do a residential roof because it has different inclinations, different shades. So for a flat roof, that will be it. Then I exit drawing. Then if I select that, see my working area is highlighted. I can choose the height of the building, probably 40. My tilt is 0 because it's a flat roof. And yeah, so if I want to automatically fill this area with the JA panels that I chose, mark you these distances that you'll be editing here are in meters. So whatever length you're selecting will be in meters, and whatever length you've input are matching the actual ground lengths and width dimensions at the ground or as built for the particular plant. Now these same lengths and widths are supposed to match up. They're going to be sized up with the panel that you chose. So the length and width dimensions of the panel that you chose. So that by the time you're selecting or highlighting, ticking this module checkbox, then the JA panels as maximum as can be installed in that, let me say, area will be automatically filled. Now these, if you zoom in, it's actually the JA panel. It takes the actual dimension of the panel and puts it on the ground so that it simulates the actual installation. If you'd like to fit in more panels or you'd like to push the panels to particular angles or sides, you go to the adjust X and the adjust Y. See, if I'm dragging it, it goes to the bottom side. If I drag it the other way, the panels move to the top side. So in this manner, you can go to the maximum number of panels that you'd like to install. So that's on the top-down movement. You can also do sideways, left to right. You drag the adjust X, adjust Y. That moves the panels into place. And yeah, so mounting wise, basically for flat roofs, we don't do flush. For flat roof, you can either do east-west. This is the most popular, east-west. So by east-west, let me drop that. Oh, by the way, so the building that I've raised looks like that in 3D. So that's how the building looks like. Now with the east-west that I selected here, mounting style, if I just zoom in, Let me tilt this so that you see what this west looks like. You can see the panels are a bit, they're slanted in east-west direction. Don't know if you can see that. So the panels themselves are slanted in east-west. You can see, yeah. So that's the most common for flat roof, east-west. But yeah, you can do whatever meets flash, tilted, or roof mounted with iron sheets or something they do flash. You can do tilted, but tilted, you have to choose a segment. You can see this segment is on this line. The green part is the segment, and it aligns with the length of the width of the panel. So you can choose another segment. Let's say segment 2, it will align with that side. If I choose segment 3, aligns to this. Yeah. But what matches this roof is actually the east-west. Now, I've already mounted my panels on the flat roof. Now, I'd like to choose which particular regions I can't mount the panels. Now, to choose this region, for example, if I don't want my panels to be at the center, then let me exit the roof part. I go to zone. So you select zone, then you select a particular zone that you do not want the panels to be. So there, click it. Then I close it off. Once that is done, I exit. You can see the panels are no longer there. It's now an empty space. It's completely empty. So that zone is basically to restrict or to remove panels that were installed. If you'd like, if you have obstacles or some, yeah, let me put it as obstacles on the roof. For example, the solar water heaters, the vents, the ACs installed on the roof. You can add them by selecting obstacle and including the obstacle. Let me zoom in. Okay, obstacle. Then I can add my obstacle. So for this particular obstacle, I can choose its height and tilt. So select the obstacle. You can choose the height, 1.5 meters, tilt probably 15 degrees. The segment that is tilting with, we choose 2. Now, once that is done, I can play around with the 3D and see what's what, how that object looks like. So that's my object. So I can do many objects. For example, we have one over here. Oops, object obstacles. Do another one here. Close it off. Okay, select the objects 5 to 15. Margin, that's okay. That's okay. Yeah. So that's another object. So you can put as many objects as you want. For example, if someone also has planted some tree on that flat roof, you can add a tree there, click, drag diameters, put another tree here, click a diameter, exit. So for the particular trees, oh, sorry, tree. Okay. Fortunately, the building is too high for the trees. So Yeah, the buildings are too high for the trees. Well, we can put a tree next to the building. Let's say over this, like this. Down, say, select the tree and put it at height. The building was 40 meters. Let me say the tree is 50 meters. The trunk height, about 15. Yeah, that makes up the tree. So such are the obstacles you can simulate. And the reason why we're inputting this obstacle simulation is because if we check on you're able to simulate how shadows are falling on the roof. So if you go on the bottom left, you'll see the hour, then there's a line. Also, what the number 12 is shown, it's now noon, 12 noon. If you want to go to the morning hours, you drag it back to, let's say, 6 or 5. Then you can drag it, simulate shadows across the day, throughout the day, and see which panels. Now, for example, in the morning hours, these panels are affected. This one not yet. Morning hours. So I can remove whichever panels I'd like to remove here. Then you drag it off to the evening hours. This is by 3. It's already on this, almost on this panel. So shadow-wise, that's how important now, including the obstacles, see how shadowing is occurring on your particular shades. Now with that, the number of panels installed on this roof, by clicking on that particular working area, it gives you a total of 307 panels and 100, giving you 184 kilowatts, 184 kilowatt of power from the PV panels, kilowatt peak. Now this, we only installed a single, we want to install a single 50 kilowatt. The 50 kilowatt can do oversizing up to 1.5, so you can do 75 kilowatt peak with that. Now, with that knowledge, the back of our mind, I have to eliminate a number of panels. So the question that you need to do is when you're, by elimination, you have to go to zone. Then the zone that you'll be drawing should not exceed or go outside the working area that you already drawn before, the location you've mounted. If it crosses beyond, for example, if it crosses behind that black line, then my zone won't be active. It won't be able to eliminate the panels. So I have to ensure that I'm restricting myself to be working within the roof that I had designed. So as long as the zone, the line that you're drawing uh, has touched a panel, automatically that panel will be eliminated. So we're down to 100 kilowatts to eliminate more. Okay. Now we are at 57. That's exit. That is too much. Need to just a bit of this. $77. Just another bit. 71. Yeah, the 50 kilowatt can do maximum 75. So 71 is just about right. Escape. So we have enough for one inverter. So you click save. Then you go to next tab, cost. Cost, this is now for the EPCs. You can input the costs that you're going to incur or whatever is going to be incurred in terms of expenses, how much to total cost, selling price, operational cost for the maintenance team. If you're doing financing, you can choose which kind of financing you're taking, how much was the interest rate, grants, whether it's a grant and the likes. So these are other details to input. Once, whether it's an EPC or it's a PPA, select which kind of PPA. Now, once you select any type of PPAs, it gives you whatever details that you can input. Okay, so that's for the EPCs and the PPAs. So click, once that is done, you click on save. Then you go to the results. Results is what gives you on um, uh, uh, the possible outcome of what you've designed. So our design will be looking something like that. Panels on east-west, the other side, that's the roof. The same design, you can simulate shadows with tilts, this to see whichever angle you'd like to see the installation. Then it gives you a breakdown of this installation size. So the kilowatt peak, the performance ratio, specific yield, savings in a year. Now, with this inverter, you can see we were supposed to select only one inverter, but it's showing two pieces of inverters there, right? Now, how to change that? We have to go to the advanced section. Then we play around with the DC-AC ratio. See, the DC-AC is on 1.2. We were targeting 1.5. Yeah, that. So save. Once you clicked on that save, the other details to play around with, for example, shading, how much you'd like to set in terms of losses, shading, soiling, and the likes, wiring losses, all that are editable. So save. Once you've done that, you have to go back to the editor part. Start from the top, again to save, push to the coast, save that, go to the results. Let's see if the inverter was not yet. Go to the advanced, okay. Let me push it to the proposal part. So to push it to the next part is to the proposal, click on share. Then cancel. So it pushes to the folder. Then when you click proposal, it's there. Let's see if interactive. Let's see if it's managed to edit. Yeah. So we go back. So we go back. Editor. Advanced. You also have a compatibility list in case you'd like to see whether this is compatible with what you've chosen. You click on this, it takes you to the compatibility. Save down. 10 out of 10. Okay, another way to prevent this is before you start the design part, before you reach this editor, or once you've just created your project, you first go to the advanced part, then choose the DC-AC ratio that you'd like to have. So you can choose 1.25, 1.3. Then by the time you're reaching on the results part, then the system already knows that you're sizing your system for the particular um, inverter, single-phase inverter or three-phase inverter, depending on the DC-AC ratio. So I'm already into the project, that's why it's not clicking in. But yeah, apart from that, the system shows you the consumption, the generation, savings in terms of generation throughout the year. Then lifetime savings for 25 years, showcase here. You scroll down, you'll get your annual generation and consumption. Because you're not really exporting, that's why you have all this. Then we have a bar chart that describes how the system operates in a monthly basis. So you can deactivate the particular colors and explain what's what. So self-consume, you have system to battery for charging, discharging, how much is still required in case you undersize. Then apart from the monthly, it's a 24-hour breakdown of how the system operates, discharge and discharging. Yeah, then I'm on a pie chart, consumption and contribution ratio. Then the ESG topics in terms of coal sales, CO2 offsets, trees planted. And yeah, that basically sounds it all. Now, with that document, if you go to the proposals, now you have two options. If you'd like to share that document online, that is interactive, you click on this view interactive. Then copy the link, you copy that link and share it, send it to the client. The client will be directly going to this display that you see right now. No editing to the plant can be done through that link. It's just an interactive way when you say access. So you can simulate the shadowing, you can explain these graphs and bar charts, deactivate and activate, and explain to the client. Yeah, so the same document, and then the client can also download it in terms of PDF. If you'd like to download in terms of PDF, then you also have some installer and designer, you have these two, download PDF. If you want table-wise, you can download data in that format. If you want hourly, download it. If you want SLD, you click on the SLD. Also, this is for AutoCAD plans. You can download this, upload it to your AutoCAD and further design it. So that will be for the SLD. So you get a simple SLD of how the system is done. So for my plant, I didn't edit the DC-AC ratio. That's why most of the strings are on this inverter. This should move to that, and then the inverter is full, just a single inverter. So with the SLD, the system gives you a breakdown of how many strings should be involved, how many panels per string, and connecting to which inverter, the rating of the breaker for the inverter. It also sizes you the AC cable. And if you're doing more than two systems, also combines and sizes the AC cable and the breaker. So it's an all-in-one solution for the design team. Caroline, I don't know if maybe we can start with the questions. So probably better tune the session to be more interactive because it's practical.
I think we'll add 10 minutes to provide time to address the questions and answers. So in case you have any questions, sorry, kindly include them in the Q&A section and all of them will be answered shortly. Thank you.
Okay, I also wanted to show, let me open this. This is in case you're doing residentials, or better yet, I can do it, project. So if it's, let me just do a quick one with this. This is for the residential houses whose roofs are a bit complex. Most of them can be single phase or three phase residential. So I'll skip the rest. The rest stick the same, but going to the edited part, you can get roofs of various skills. So for this, let me just pick the two shades. I'll click on roof, then I draw the first shape. So if you have all the first inclination, if you have 5 inclinations, you have to generate 5 roofs. So for this, I have 2 inclinations or faces or shapes. So I'll just generate 2 roofs. So this will be my first roof. That's my first roof. I need to give it height. So probably 10. Tilt, give it 13. It's drawn. To select that, tilt this. Let me increase the tilt. 8, 12, 13. So you can see it's tilted in the wrong direction. I want it to tilt facing the other side. So to change that, you change the segment. The segment is the green line that you're seeing highlighted. So I want it to be either on this side or on that side. So I can do number 2. Yeah, number 2 gives it the correct tilt, tilted on that direction. So that roof is done. I have to do another roof. So for all the roofs or angles that you have to generate its own roof. Height, same height, 10, tilt, 15. But then I need to check whether it's tilted the wrong way. I think segment 3, not 3, 7, 4, yes. So with that, I've already built a roof. So for residential, you have to build as many roofs depending on the number of tiles that you have. Then similarly, the rest is the same. Select the roof or to fill the panels. You can also select the other roof or to fill the panels. If you want to click install walkways, you'll have to use the same zone because you're excluding some panels. So exit draw, go to zone, then draw, let me say a rectangular line. So in that way, you can draw your walkways or eliminate space just to simulate which walkways you're going to install. Okay, so let's think we'll start with the question so that finish up with the training session.
Okay, Silas has his hand up. Silas, kindly unmute. Silas? Silas, kindly unmute yourself. Okay, as we wait for Silas, let's address the questions. Edward Kopondo has a question. How would you redesign with a roof having a CAD drawing that is a proposed non-existent building?
Okay, so with an existing building, basically you'll have to, hopefully you have a plan for the building, because as you can see, we are actually constructing our own buildings. So if you have a plan for uh, the building that is going to be installed, then you can use the floor plan and the side view and the rest of the views that you can get from those drawing, the architectural drawing, so that you get a perspective or a view of how the roof is going to look like and how much tilts and how much, let me say, faces and shades that you're going to have for that roof. So that should be enough to give you something to construct a roof for.
Okay, thank you, Patrick. Edward, I hope your question has been answered. Silas, kindly proceed. Silas, kindly unmute. Okay, as we wait for him to unmute, um, we have Jean. Does GoodWe have power optimizers for solar panels? Patrick,
Hello? Yeah.
does GoodWe have power optimizers for solar panels?
Well, power optimizers are not so popular in Africa, because by the design part, the technicians usually avoid any shadowing conditions. But in case you'd like to use power optimizers, we are compatible with third-party power optimizers like Tigo and the likes. So we have another other compatibilities with such kind of optimizers.
Okay. We have Silas, so he wasn't able to talk. His question is the tool designs integrating, yeah, does it integrate with gensets?
So with
The,
gensets, the controllers we have are not diesel hybrid um, PV controllers, but our products, the inverters are compatible with third-party controllers. So what you'll need are third-party diesel hybrid controllers like Dave, Bluelog, Elom, and the likes, which are compatible with GoodWe. So we do have case references. So if you want to do diesel hybrid controllers integrating with GoodWe, we can refer you to third-party controllers that can uh, help you execute such kind of systems.
okay, Silas, I hope your question has been answered. Another question from the game. Does this tool, which is a GoodWe designer, fully replace the physical assessments? Asking from Ethiopia.
Fully replace physical access. Well, now the images that you're seeing here are from the PV, so you have to choose. Basically, they are online. So, for example, this we are getting it for this meteorological data, PVGs, and the likes. So basically, we are depending on other third-party systems too, like the Google Maps and the likes, to get your aerial view drawings. So the exact dimensions that you'll need, if you want to be far more accurate, then you have to do a site visit to get the exact dimensions, because these are images from the satellite. If it's not visiting the site, then you need the actual architectural drawing so that you get to know the exact dimensions of the floor plan, the roof dimensions, and the lights. Also, you have to do a physical visit in case the images are outdated. Probably there are other obstacles that were not there 4 or 5 months ago. So site visit should be able to eliminate such kind of let me say, unforeseen instances. So not fully eliminating your as-built drawing. You have to confirm with architectural as well as site visits.
Okay, a question from Eric. Hi, do you offer software or we need to purchase?
So this software is for free. All you need to do is just register as an installer, and then you'll have access to this GoodWe Designer tool.
Okay, question from Omoy. Is GoodWe open to third-party monitoring tools, access like SCADA? Also, if GoodWe can share details for the same for lithium battery.
So with SCADA third-party systems, we have two options. You can either do the API integration. Well, API is now basically our monitoring portal. SAMs will be pushing data or will be responding to your third-party, let me say, third-party monitoring portal. So data transfer from SAMs to your third party. That's one way. The other way is through SCADA. So we have our controllers that can be integrated using SCADA. So our EasyLogger 3000C, our SEP 3000C, you can use these controllers and then you can be able to integrate through SCADA with the Modbus TCP, Modbus RTO.
Yeah.
And for the batteries, I didn't quite get the question for batteries.
Yeah, me neither. Omoy kindly clarify that on the batteries. We proceed. Jane asked, can you design a roof with several slopes?
Exactly. So with the several slopes, just like I've just shown here for this particular project, it only had two slopes. That's why I developed two roofs. If you have 7 slopes, then you'll have to develop 7 roofs. Now, the 7 roofs you can install in as many. So, for example, if I have this, if there was another roof here, I can still go to edit. Let me exit this. Then I can add another roof. Let's say most you can do this kind of a shape, triangle. In case we had such kind of building, then I give it height 10 meters, tilt 13. It's very possible. Now I have to check how it's tilting. It's not the correct way. So change the segment. Yeah. So such kind. If you have different rules, different, it's just that now I'm doing it, it's not really working out because this roof is not designed for this. But if your roof is of different tilts, you can very, very much achieve it.
Okay. Jean also asks, can you explain the choice of inverter in relation to the solar panels when the software returns an error?
Okay. Now, when the software returns an error, it's basically on the MPPT rating. So the short circuit current of the panel, the ISC of the panel is exceeding the maximum ISE short circuit of the MPPT. So for example, if the MPPT is 10, let's say 20 amps maximum, yet you have a panel that has a short circuit that reaches probably 26 amps. Already that is, if you connect that and there's a short circuit, then the panel will damage the DC bus of the inverter. That is, the short circuit is what damages the DC bus. But if your generation current, IMP, maximum generation, is exceeding the MPPT maximum operating current, but not exceeding the short circuit current, then the inverter will just clip, in short, just clip the current. If the panel was to reach 20 amps, let's say 17 amps, but the MPPT maximum is 15 amps, the MPPT will only allow 15 amps. It clips away the 2 amps. So what the software looks at is the short circuit of the panel and the short circuit and the maximum short circuit of the MPPT. So these you can get from the datasheet of the panel and the datasheet of the inverter just to confirm how much you're working with in terms of current.
Okay, and this additional question is, are we obliged to specify the products to be used for the project at the beginning of the design process? Can't the software automatically generate basic materials according to my energy requirements?
Not really. For example, in Africa, the residential sector are basically hybrid, but we do have residential grid type. So it's your solution will be tuned to your client's needs. The software will not automatically know what you'd like to install. For example, we also have hybrids with uh, IP ratings, IP65, but then you have a client who doesn't require IP65, wants IP21. So you have to choose depending on the client's needs, and then the rest will just stick to the same. So first off, before you design, you have to know what the client really wants. Is it IP65 inverter or IP20? Is it a three-phase in system or a single-phase system? Is it so that such kind of data you need to get them prior to beginning this kind of design with the GoodWe design.
Okay, question from Simon Gitenji. Is the 3D modeling available everywhere? Other softwares are unavailable or limited to Africa?
Yeah, so this is
Africa.
global.
Mhm.
Yeah, so our design tool is a global tool. So Europe also uses the same tool. Africa, US, Asia, we're using the same tool. So it's a global tool. As long as you have the installer account, you can access the GoodWe Designer tool.
Okay. We have a question from Yusuf. Can we consider the design tool from GoodWe, which is a GoodWe design, and compare it to a design from such software designs like SketchUp and others?
Yeah, actually, the designer is much more better than SketchUp because it's uh, real time. We are getting data as per the latest products, as per the latest weather conditions to give you an accurate simulations of whatever you would like to design. So this product is enough to push to help you simulate and propose a solution to a client. It's very accurate. So that's why we're actually promoting it. And it's very tuned to our product. So if you have a GoodWe product, then the GoodWe designer is very much tuned to help you in designing your system.
Okay, thank you very much, Yusuf. I hope your question has been answered. Question from Mary. Kabiru, are there any tools or guidelines GoodWe provides for optimal inverter placement and system layout?
Tools, okay. From our manuals, basically what you get from our manuals will be on the inverter side. Now, on the inverter side, it will give you the spacing, the temperature required, mounting area, and the lights, the cable ratings. Now, on the panel side, it's basically typically what you'd want to achieve is that in a single MPPT, the panels or the strings connecting to that MPPT should be facing the same direction and should be having equal strings, equal panels, number of panels per string. So the voltage should be almost balanced and the direction the strings facing should be the same so that you don't have a voltage imbalance. If you have a voltage imbalance to strings that are connected to the same MPPT, then you're risking backfeed. In short, the panel with higher voltage will be feeding power to the strings with lesser voltage. So there are certain conditions that we can, let me say, layout. It depends on the site conditions. But yeah, we can come up with the documentation to try capture all these, because most of the parameters are not just focusing on the inverter, but also focusing on the losses on the DC cables, losses on the panels, how you should install your panel to ensure maximum efficiency, to get a fully efficient system. So yeah, on the inverter side, we are covered with the manual, but we'll try get document that can also inform you on what you should do from the panel side and the cable sides of the system.
Okay, question from Simon. He says that he wasn't there from the start. So he asks, is this software for free? The GoodWe design, is it for free online, or do we have to pay for licensing? And so can you use other inverter models other than GoodWe?
Okay, so the software is free. You just need to install, register as a SAMS install account, and the same logins are the same logins you'll be using to access the GoodWe designer. The other question is, this tool is only for GoodWe products, strictly GoodWe products and no other third-party products. It's very much tuned for GoodWe.
Okay. Uh, Another question is, I think now from Omoe, for GSM operations, we may need to integrate with third-party controllers, etc. To integrate them all, we may need GoodWe to open some ports. Is this possible?
Open support with third-party controllers. Well, if you'd like to simulate with third-party, I think now you'll have to go with the other third-party design tool. For GoodWe Designer, we're basically just simulating with the GoodWe products. So the GoodWe inverters, GoodWe batteries, and the likes. If you'd like to do third-party controllers, um, then yeah, you'll have to now use a third-party design tool.
Okay. So I have a question here from Jane. Can you show the printing part of the project again? Because of time, we will share the webinar recording, so kindly feel free to go through it again. Question from Afriye. Thank you, Patrick. With the editor feature on the roof, is there a way to split each half to east-west orientations as opposed to the back-to-back we see? Assume I want an all east or all west tilt.
Yeah. So if you'd like to do that, then there is a manual way of laying out the panels. So basically, let me just highlight it. If I can uncheck the modules part, if I want to do then exit, I can select modules. Then immediately I go there, click, drag, finish that, escape. Then I select this, I do tilted, choose different segment. Yeah. So if I choose that and I choose tilts, exit, selected the wrong one. Yeah, so in that sense, just ran out of time, but you can do it manually. Choose modules, modules, then manually lay out your panels. Then after that, select the modules you've installed, then choose tilted. Yeah.
Okay. Another question. Francis, the GoodWe Designer software does not include the balance of system materials, right?
Yeah, it doesn't include the balance of system. It's basically just to show you which sizings, just for the sizings. Cable sizing, inverter sizing, battery sizing, panel sizing. Not all of the balance systems like the structures, the the cable trays and the lights. Not all the rest. Just for sizing the system in terms of power generation and distribution.
Okay. Question from Edwin. Does GoodWe offer a remote cloud management app?
Yes. So the remote cloud management app is called SAMS, and we are recently just launched the SAMS Plus for the mobile app. We are also going to launch the SAMS Plus for the web version in July. So our monitoring portal is called SAMS. It's free. You just reach out to your App Store or Play Store, type SAMS Plus, and that will be the monitoring remote monitoring account or portal that you'll be using for the GoodWe products.
Also, to add on that, we also recently had our SAMS webinar. So feel free to click the link on the chat box to go to the webinar and learn more about SAMS. Okay, due to time, I'll take up two more questions. So, Brian, does your tool allow uploading of architectural layouts or 3D models for modeling the solar panels?
Now, at the moment, no. Basically, we would like to put it as interactive. So you build the 3D yourself so that you get to adjust whatever changes are, so that you make it as built as possible. So at the moment, we are not yet allowing the uploads of 3D data to help you facilitate the design.
Okay. Thank you very much for that. One more question. Let me see. Okay, so Jane is asking. So he's currently working with a different vendor. So his question is, what argument can we give to persuade the customer to switch to GoodWe? Yeah, basically that's the question. Because the vendor offers power optimizers, which is the plus for maximum energy efficiency.
Okay, John, for this, I think you need a good argument. So I'll share with you data on how we can uh, push the customer to take in the GoodWe products. I'll give you the unique points, selling points that GoodWe has in contrast to the other inverters that we have in the market right now.
Okay, so I see that a couple of people are trying to register, but they are experiencing issues. So I think to sum up, Patrick, you can let them know the initial procedure of logging into GoodWe Designer.
Okay, just a second. Well, as I mentioned before, first, the GoodWe Designer is linked to your installer account. So you first need to register as an SAMS install account. We'll also share the install account registration link after the webinar. Then once you've registered, let me log out first. So once you've registered, you just go to your browser and type in GoodWe Designer. So you'll be prompted to this page. So this page actually, it wants you to get it will like to get your details for the same login account. So if you have the same login account saved in your browser, just click on the GoodWe SAMS, then it will go retrieve data for the SAMS install account login and automatically populate. Then once that is done, you click on sign in. Then automatically the system will sign you in to the GoodWe Design account. And then, yeah, start your projects by clicking new project. And the rest, we'll be sharing our webinar so that you can see how the designing is done.
Okay, thank you very much. So there are people asking for the GoodWe SEMS webinar YouTube link. So I'm sharing that on the chat box. Kindly have a look, shared. And just a kind reminder that tomorrow we'll be participating in the AFCIA e-conference on storage. And we'll be having our session from 12:15 to 12:45. Patrick will be presenting. So kindly register for you to join the session. It will be very informative. And what we'll focus on is on storage trends, which is a really great topic for us, especially at this time when people are shifting to renewable energy storage. And use that link to register. So thank you very much for attending our webinar today. And we'll also have a small test. Once you pass the test, we'll issue you a certificate, which you're free to share on your social media platforms and also with your customers to show them that you already have the enough knowledge to support them in their projects. Thank you very much for coming today. So Patrick, kindly close.
Thank you. So looking forward to your attendance tomorrow for the AFCIA webinar. So we'll be talking about trends in the residential energy storage system and the C&I storage system and how GoodWe is actually impacting this move or this trending process for the solar PV systems. So happy to train you again. So monthly, we'll also be having our next webinar next month. I think we'll share the links to the next upcoming webinar as you receive this training for this link. Have a good day.